Hello student, once again welcome you all. In this lecture we'll discuss about the basic of trigonometry. In the previous lecture also we have discussed some points in the trigonometry. Okay, that will help to understand the basic concept in the trigonometry. Now let us discuss them one by one. What actually the topic we will discuss in this today's lecture. So first is trigonometric functions of allied angle. What is in by allied angle and what are the result actually related with this concept that we will discuss. Second part is trigonometric functions of multiple angle. In the multiple angle 2 theta 3 theta, these two types of result we will discuss. And last is factorization formulas. So in this third factorization formulas, there are actually two basic concepts. First is factorization and second is defactorization. So we will discuss them one by one. So let us start with trigonometric functions of allied angle. What is in by allied angle? First we'll see that if the sum or difference of measure of two angle is either 0 or in the integral multiple of pi by 2, then the angle are said to be what allied angle. And now we are going to learn the result which are related to allied angle. Allied angle means what? The sum or difference of measure of that two angle is either 0 or in the integral multiple of pi by 2. Means 3 pi by 2, 4 pi by 2, like this. 4 pi by 2 means 2 pi. Okay, then 7 pi by 2, 5 pi by 2, so on, plus minus theta. Okay, so the allied angles is of this form. So theta is the measure of an angle minus theta, pi by 2 plus minus theta, then pi plus minus theta, 3 pi by 2 plus minus theta, then 2 pi minus theta, 2 pi plus theta, like this. So these are all what allied angles. So in this type of angles are called as allied angle, and we are going to discuss the result formulas related with them. Okay, so let us discuss the formulas. Actually bifurcate them into two parts. Okay, so in which two part, let us see that. Okay, first is pi by 2 n pi by 2 plus minus theta, and second is n pi plus minus theta. Okay, once if you understand this bifurcation, then it is very easy to remember all the results which are related to this allied angle. Okay, so what are the types of angle in n pi by 2 plus minus theta? So this is what pi by 2 plus minus theta, 3 pi by 2 plus minus theta. In this lecture we will discuss the formulas related with these two, pi by 2 plus minus theta and 3 pi by 2 plus minus theta. And in the n pi plus minus theta, so pi plus minus theta and 2 pi plus minus theta, these two types of formulas are there. Okay, so we will discuss the formulas related with these four concepts: pi by 2 plus minus theta, 3 pi by 2 plus minus theta, pi plus minus theta, and 2 pi plus minus theta. So let us discuss first n pi by 2 plus minus theta. Okay, so n pi by 2 plus minus theta, again this is what happen with the formulas. Okay, so if you are going to construct the formulas for n pi by 2 plus minus theta, what happen actually, what should be the answer of the allied angle, what should be the formula for these all angles. Okay, so what happened, first thing is what ratio will change. Ratio will change means cos changes to sine, sine changes to cos, tan changes to cot, cot changes to sec, cot changes to tan, sec changes to cosec, and cosec changes to sec. This is the basic difference. Okay, this is very important concept to remember these results. And second thing which will happen is what sign of the answer depend on the quadrant in which the angle is present. Okay, you just have to check that angle is in which quadrant. Okay, because in previous lecture we have seen that some ratios, okay, are particularly positive in particular quadrant and other all ratios are negative. One statement, it is a very popular statement we have learned. Okay, and what was that? Add sugar to coffee. And that diagram also we have seen, take a from add in the first quadrant, all ratios are positive in the first quadrant. Take s from second word sugar and take it in the second quadrant, then sugar means sine and its reciprocal cosec are positive in the second quadrant, all are negative, and so on. These all things we have learned. Okay, so now today just we apply them here to construct the results of allied angle, trigonometric functions of allied angle. So ratio will change means what happen, sine changes to cos, cos changes to sine, tan changes to cot, cot changes to tan, sec changes to cosec, cosec changes to sec. And sine means what, that I have explained. In the first quadrant all ratios are positive, in the second quadrant all sine and cosec are positive, in third quadrant tan and cot are positive, in the fourth quadrant cos and sec are positive. Cos and sec are positive. Okay, means suppose if your angle is in first quadrant and if you want cos pi by 2 minus theta, cos pi by 2 minus theta. See, pi by 2 minus theta is in which quadrant? First quadrant. Okay, so the and cos is also positive in the first quadrant. So your answer is what? Sine theta. Cos pi by 2 minus theta is nothing but sine. That result we will discuss. Okay, because in the first quadrant all ratios are positive and pi by 2 minus theta is in first quadrant. Therefore, all ratios are positive and cos changes to sine. With the help of this, cos changes to sine and therefore cos pi by 2 minus theta is nothing but your sine theta. Did you get this? Okay. See the formulas. First, sine pi by 2 minus theta is equal to cos theta. Ratio changes. Sine changes to cos. Cos changes to sine. Tan changes to cot. See here. Okay. So ratio will change. Ratio will change here. So if you see this, sine changes to cos. Cos changes to sine. And tan changes to cot. Okay. And your pi by 2 is what? Pi by 2 minus theta belongs to first quadrant. Okay, and in first quadrant all ratios are positive. All ratios are positive. Therefore, what? Therefore, answer is plus cos theta. This is cos theta. Sine pi by 2 minus theta is nothing but plus cos theta. Cos pi by 2 minus theta is nothing but sine theta. And tan pi by 2 minus theta is nothing but cot theta. Tan changes to cot, sine changes to cos, cos changes to sine. Okay. Also, you will construct for sec and cosec. They are also same. So this is the first formula. Next is what? Next is sine pi by 2 minus theta. This is plus, not minus. This is print mistake. So sine pi by 2 plus theta is nothing but cos theta. Because pi by 2 plus theta is in which quadrant? See, this is 0 here, pi by 2. And pi by 2 plus theta is in third quadrant. Pi by 2 plus theta is in third quadrant. And in third quadrant, sine is positive. Sine theta is positive in the what? In the third quadrant. Sorry, second quadrant, not third quadrant. This is not the third quadrant. This is the second quadrant. In second quadrant, sine is positive, sine and its reciprocal cosec is positive. Therefore, see, answer is sine changes to cos. This is the basic concept. Cos changes to sine and tan changes to cot. Isn't it? Only the confusion is for the sign. What is the sign of the answer? Sign of the answer is depend on the angle quadrant in which angle is present. Okay, so pi by 2 plus theta is in present in second quadrant and in second quadrant sine is positive, therefore your answer is positive also. Cos pi by 2 plus theta is nothing but sine theta, but here it is minus because in second quadrant cos is negative. Cos is negative in the second quadrant, therefore your answer is negative. Okay, also tan is negative in the second quadrant, therefore your answer is negative here, minus cot theta. Get it? Okay. So in this way we can construct the formulas that are related with this all angles, allied angle. Okay, so this is about the pi by 2 plus theta. Now what about 3 pi by 2? See, this is sine 3 pi by 2 plus sine 3 pi by 2 minus theta. 3 pi by 2 minus theta is in third quadrant, and third quadrant sine, see here basic is what? Sine changes to cos, cos changes to sine. Got it? See here this is your sine changes to cos, cos changes to sine, tan changes to cot. Okay, so my only the confusion for the sign. Okay, so sine is answer, sign of the answer. Sine is negative in the third quadrant, therefore answer is minus. Cos is also negative in the third quadrant, therefore answer is minus. But tan is positive in the third quadrant, therefore it is positive. Cot theta. Got it? And last is for sine 3 pi by 2 plus theta. Sine again, sine changes to cos, cos changes to sine, and tan changes to cot. So sine is negative in the fourth quadrant. 3 pi by 2 plus theta is in fourth quadrant. Okay, and that is negative in the fourth quadrant, and therefore answer is your negative. But cos is positive in the fourth quadrant. Add sugar to coffee. Cos and its reciprocal sec are positive in the fourth quadrant, therefore that answer is positive here. See, this is positive. Okay, and also tan is negative in the fourth quadrant, therefore its answer is negative, minus cot of theta. Okay, do you understand? In this way we can construct the formula. Just two things you have to remember here. So if n pi by 2 plus minus theta is there, sine changes to cos, cos changes to sine, tan changes to cot, cot changes to tan, sec changes to cosec, cosec changes to sec. Okay, you can also construct the remaining results for sec and cosec also, and cot also, from this basic idea. Okay, so just focus on the sign. Sign of the answer is depend on the quadrant in which angle is present. This is a very important thing, understand? Okay, n pi plus minus theta, what happens? Same here, but the basic is what here. First thing, sign will remain, ratio remains same, ratio will not change, means sine remains sine, cos remains cos, tan remains tan, sec remains sec, cosec remains cosec, ratio will not change. But sine is also depend on what the the quadrant in which the angle is present, same as that before. Okay, so ratio remains same is what, sine same as sine, cot same as cot, cos same as cos, tan same as tan, sec same as sec, and cosec same as cosec. Okay, and the sign of the answer is depend on the quadrant in which angle is present. Yeah, that we have discussed earlier. Okay, let us see the results. So first is sine pi minus theta. See here, basic is what, sine is remains sine, cos remains cos, tan remains tan. Did you get this? Okay, so pi minus theta is in which quadrant? Second quadrant, and second quadrant sine is positive, therefore answer is positive. Cos is negative in the second quadrant, therefore answer is negative. Also tan is negative in the second quadrant, therefore answer is negative. Okay, second is pi plus theta is in third quadrant. In third quadrant sine is negative, therefore answer is negative. Cos is also negative, therefore answer is negative. Only tan is positive, therefore answer is positive. Okay, and ratio same, sine changes to sine, cos changes to sine, cos as same as cos, and tan is same as tan. Got it? Okay. Now sine 2 pi minus theta. 2 pi minus theta is in, I think, fourth quadrant. This is fourth quadrant. Okay, and in fourth quadrant sine is negative. This is minus. Okay, see, sine remains sine, cos remains cos, tan remains tan here. Okay, and in last quadrant cos is positive. This is positive actually. This is not negative. This is print mistake. Okay, cos 2 pi minus theta is nothing but plus cos theta, and tan 2 pi minus theta is nothing but minus tan theta, because tan is negative in the fourth quadrant. 2 pi minus theta is in fourth quadrant, and the last is what, sine 2 pi plus theta is in first quadrant. Okay, and in first quadrant all ratios are positive. This is plus, not minus. All ratios are positive, not this is minus actually. This is plus, this is also plus. All ratios are positive. Okay, sine changes to sine, sine remains sine, cos remains cos, tan remains tan. There is no change in the ratio. Ratio remains same. See here, ratio remains same, and because 2 pi plus theta is in first quadrant, 2 pi plus theta is in first quadrant, therefore all ratios are positive, all answers are positive here. Got it? Okay, so in this way we can construct the formulas that are related with the allied angle. Also you can construct the formulas for sec, cosec, and cot. That three formulas are remaining. You can uh, use the same procedure. Okay, so ratio remains same, and sine is depend on the quadrant in which angle is present. Got it? Okay, so this is the overall summary of this topic. Okay, so angles and ratios. Sine minus theta is nothing but minus sine theta. Cos minus theta is nothing but cos theta. Tan minus theta is nothing but minus tan theta, and so on. We have discussed all these concepts. Okay, so in this way we have seen the result that are related to allied angles. Okay, so let us see some examples that will help you to understand the concept. Sine 495 is equal to what? What is the value of sine 495? Now write this 495 in the integral multiple of pi by 2 or pi. So 495 can be written as C. It is nothing but simply what, 360 plus 135. Now this is your theta. 360 means 2 pi. 2 pi plus theta. Sine 2 pi plus theta is nothing but sine theta. That result we have. Okay. So that result we have used, sine 2 pi plus theta is nothing but, sine 2 pi plus theta is nothing but, ratio will not change. This is sine theta, and this is in first quadrant, therefore answer is positive also. Sine 135. Again 135 can be written as pi by 2 plus 45, 90 plus 45. 90 plus 45 is nothing but pi by 2. And sine pi by 2 plus theta is in which quadrant? Second quadrant. And second quadrant sine is positive, and sine changes to cos because of pi by 2. Okay, and cos 45 is nothing but 1 upon root 2. This is the answer. Same here for cos 930. 930 can be written as 2 into 360 plus 210. Okay, 4 pi plus theta in this way. This is actually 4 pi. Okay, this is actually 4 pi. 2 pi into 2 pi. So 2 into 2 pi means 4 pi plus theta. And the ratio will same. Ratio remains same. And 4 pi plus theta is in first quadrant. Therefore, answer is also positive. And cos 210 can be written as pi plus 30. Cos pi plus 30 is nothing but minus cos 30, because pi plus 30 is in which quadrant? Pi plus 30 belongs to what? Third quadrant. And in third quadrant, cos is negative, and therefore answer is negative here. See, therefore cos 30 and cos 30 is nothing but root 3 by 2. See the table that all values are from the table. In the previous lecture, actually we have seen the all the values. Okay, we have taken the five numbers 0, 1, 2, 3, 4, 5. Sorry, 0, 1, 2, 3, 4. Divide them by 4. Okay, take a square root and all that values is that table we have seen. Understand? And all the values I just now use that on the table. Okay, to for the values of cos 45, cos 30. Isn't it? Okay, now one more example, let us see here. That is tan 840. What is tan 840? Again same, 840 can be written as 2 into 360 plus 120. This is your 4 pi. This is what? This is your 4 pi. Again 4 pi plus theta. 4 pi plus tan remains tan 120. Okay, again tan 120 can be written as pi by 2 plus 30, and tan pi by 2 plus 30 is nothing but minus cot 30, and your answer is minus root over 3. Got it? So in this way we can use that all formulas, allied angles, formulas, trigonometric functions of allied angles to find the answers. Okay, so maybe this all type of examples we will use in some technical subject or in higher mathematics also, higher engineering mathematics also. Okay, hope you have understand this. Okay, let us move to the next. Trigonometric functions of multiple angles. What is the concept of trigonometric functions of multiple angle? Now multiple angle is divided into two types actually, 2 theta and 3 theta. What is in by trigonometric functions of multiple angle? The angle of the form 2 theta, 3 theta, 4 theta, etc. are multiple of theta. These angles are called as a multiple angle, and the angle of the form theta by 2, 3 theta by 2, etc. are called as submultiple angle. Multiple and submultiple, or otherwise this theta by 2 is also called as a half angle formulas. The angle formulas related with theta by 2 is called as a half angle. This theta by 2 is called as a half angle. 2 theta, 3 theta, 4 theta is multiple angles. Okay, so now these trigonometric functions of multiple angle can be divided into two parts. First is trigonometric functions of double angles 2 theta, and trigonometric functions of triple angle 3 theta. Got it? Okay, now discuss them one by one. First is trigonometric functions of double angle 2 theta. So there are three results actually for sine 2 theta, cos 2 theta, and tan 2 theta. Let us see them. So sine 2 theta is nothing but 2 sine theta cos theta. And also this is same as 2 tan theta divided by 1 plus tan square theta. This is also one more result for sine 2 theta. Now for cos 2 theta there are four results. First is cos square theta minus sine square theta. Second is 2 cos square theta minus 1. Third one is 1 minus 2 sine square theta. Okay, so this one, and last one is 1 minus tan square theta upon 1 plus tan square theta. Depending on the expectation from the example, we will use the different formulas for cos 2 theta, sin 2 theta also. Okay, so there are total four formulas for cos 2 theta. This is very important. Okay, and you can also use them for the different steps. Okay, which step is there and which formula is useful actually for that particular step, that formula we will use. Okay, so you can use any out of these four. You can use any out of these two. Okay, so and the last is tan 2 theta. So for tan 2 theta it is 2 tan theta divided by 1 minus tan square theta. So these are the formulas related with double angle, trigonometric functions of double angle. Now trigonometric functions of triple angle. Sin 3 theta is nothing but 3 sin theta minus 4 sin cube theta. Cos 3 theta is nothing but 4 cos cube theta minus 3 cos theta, and tan 3 theta is nothing but 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. See the difference of these two. Only these two terms are shuffling of these two terms. Sin 3 theta, 3 sin theta minus 4 cos sin cube theta, and for cos 3 theta, 4 cos cube theta minus 3 sin theta. Isn't it? Okay, and tan theta is nothing, tan 3 theta is nothing but 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Okay, so in this way we have seen these two types of result, trigonometric functions of multiple angle. Hope these results also help you to understand the concept of trigonometry. We will use these all formulas and also some concept of mathematics. Okay, show this 4 sin theta into cos cube theta minus 4 cos theta into sin cube theta is nothing but 4 sin theta. So just we have to prove this. Okay, now the solution is consider LHS, and from that we will show the RHS. Okay, so take 4 sin theta cos theta common because it is present. 4 is present here also and here also, take it common. Sin theta is there also. Sin theta cos theta is there also. Take it common. What is there inside the bracket? Cos square theta minus sin square theta. But what is cos square theta minus sin square theta? This is nothing but cos 2 theta. That result we have seen earlier. Okay, and I just separated 2 sin theta cos theta I have written, but 2 sin theta cos theta is again sin 2 theta. Okay, and therefore we can have 2 sin theta into cos 2 theta, but we know the formula sin 2 theta is equal to 2 sin theta cos theta. If we double the angle, means instead of 2 theta if I write the 4 theta, then what I get, 2 sin 2 theta into cos of 2 theta. Also this angle will get double. Okay, if we double this angle also will get double, and therefore the value of 2 sin 2 theta cos 2 theta is nothing but sin 4 theta, and that is your RHS. Okay, so in this way we can use that double angle and triple angle formulas also to understand the concept of multiple angle, trigonometric functions of multiple angle. What is the factorization formulas? Okay, formulas for conversion of sum or difference into product. Suppose we have sine A plus sine B and we want it in the product, then what will I do? Okay, so that in that case we use these formulas for conversion of sum or difference into product, and another way formulas of for the conversion of product into sum or difference. Inversely, actually opposite of each other, factorization, defactorization. Okay, formulas for conversion of sum or difference. Let us consider the two addition formulas. So this is sin c plus sin d is equal to 2 sin c plus d divided by 2 into cos c minus d divided by 2. Second formula that we have is sin c minus d, 2 cos c plus d divided by 2 sin c minus d divided by 2. What is the only difference? We just have changes the position of sine and cos. See here, but remaining terms are same. Only the position of ratios are different. Sine, then cos, and in the sin c minus d, first cos and then sine. Get it? Okay. Now cos c plus cos d is what? What is cos c plus cos d? 2 cos c plus d upon 2 cos c minus d upon 2. On both position there is cos for cos c plus cos d. Okay, there is cos, there is no sine. And what about cos c minus d? Cos c minus cos d. Okay, it is either 2 minus 2 sin c plus d upon 2 or sin c minus d upon 2, or otherwise if you reverse the position of c and d here, then plus is here. Minus 2 is not here, plus is here. Okay, so if we take minus, then sin c plus d upon 2 sin c minus d upon 2, or otherwise if you want plus, 2 sin c plus d upon 2 sin d minus c upon 2. Okay, in sin c plus sin d or sin c minus sin d, combination of sin and cos is there, but in cos c plus cos d only cos is there, and cos c minus cos d only sin is there. See, only sin is here, ratio is only sin. For minus there is sin, for plus there is cos. These are the formulas of conversion of sum or difference into product. See, there is a sum, sin c plus sin d, and now here it is product, sin into cos, sin c plus d by 2 into cos c minus d divided by 2. Got it? Okay. And With the help of that, we can prove this cos 40 plus cos 50 plus cos 70 degree plus cos 80 degree is equal to cos 20 plus cos 10 degree. Okay, so consider the LHS same here, cos 40 plus cos 50 plus cos 70 plus cos 80. So add them. So actually cos 80 cos 40 even angles 80 and 40, and cos 70 plus cos 50. So use the formula of cos C plus D. Here again cos C plus cos D. Okay, cos C plus cos D is 2 cos C plus D divided by 2, cos C minus D divided by 2. Same here for cos C plus D divided by 2, cos C minus D divided by 2. Okay, 80 plus 40 divided by 2 is nothing but 60. 80 minus 40 divided by 2 is nothing but 20. Same here 70 plus 50 divided by 2 is nothing but 60, and here 70 plus 50 divided 70 minus 50 divided by 2 is nothing but 10. So take 2 cos 60 common, cos 20 plus cos 10, and cos 20 plus cos 10, cos 60 is nothing but 1 by 2, the value of cos 60 that I have replaced here from the table that we have in the previous lecture. Okay, so this cos 60 is equal to 1 by 2, that value I have replaced here. See, this is the value of cos 60. 2 to get cancelled, you get cos 20 plus cos 10, isn't it? So in this way we have seen this concept. Now second is formulae for conversion of product into sum or difference. So product into sum or difference, let us consider the two results and add them. Take the addition, sin a plus b. In the previous video we have seen this. Sin a plus b is nothing but sin a cos b plus cos a sin b. Sin a minus b is nothing but sin a cos b minus cos a sin b. So if we add them, what I get, this get cancelled. See, cos a sin b minus cos a sin b get cancelled. Sin a cos b plus sin a cos b is nothing but 2 times sin a cos b, and sin a plus b is here, and sin a minus b is here. So if we shift this 2 in this side, what I get, or 2 sin a cos b is nothing but sin a plus b plus sin a minus b. In this way we can construct the all results of sum product into sum or difference. Okay, see this 2 sin a cos b is nothing but sin a plus b plus sin a minus b. 2 cos a sin b is nothing but what, simply sin a plus b minus sin a minus b, and cos 2 cos a cos b is nothing but cos a plus b plus cos a minus b. 2 sin a sin b is equal to cos a minus b minus cos a plus b, with the help of this basic idea. Okay, and all the result that we have seen for addition and subtraction in the previous video. Okay, just refer that all results and take the appropriate results and add them. You will get these all results, four results for formulas of conversion of product into sum or difference. Let us see some result example. Okay, depend on this to express the sum or difference of the two trigonometric functions. Express as sum or difference of two trigonometric functions. 2 sine 4 theta into cos 2 theta. Okay, so this is nothing but see 2 sine 4 theta into, see this is sine a into cos b. So sine a plus b plus sine a minus b. It is sine 60 plus sine 20. In this way we can use that. You remember all these things, all these formulas, still it is okay to understand the concept of trigonometry, and definitely this will help you to understand the mathematics in the higher level, and also these all formulas will help you to understand the derivation from your technical subjects also. Okay, thank you. In the next lecture we will discuss the basic of derivative and also basic of integration. Okay, thank you once again.